In section 7.4, we're going to look more specifically at inverse trigonometric functions. So you've used inverse trig functions already to help you solve for angles. But we've used it just as a tool for solving. We haven't actually looked in depth at the inverse trig as its own separate function. So we're really going to look more in depth at these inverse trig expressions as their own functions. So I'm going to give you a little bit of background at what they are and kind of why they are the way they are. And also why we get the kind of answers back that we do, especially on the calculator. If you remember back in chapter 6, sometimes when we did a problem that involved inverse trig, we couldn't always use the answer the calculator gave us. Sometimes we had to adjust that angle that it gave us and move it into the correct quadrant. And there's a reason for that. And the reason is the calculator treats the inverse trig as a function. So one input could only give back one output, even though there's technically two possible outputs. So I'm going to show you exactly why, and we'll go through some examples. And then there's really only two types of problems in this section. It's a fairly short section. And there's also some composition problems. So first, our inverse trig functions. I'm going to start with the regular trig functions, and we're going to do a little flashback to algebra, where we learn about inverse functions in general to kind of derive what the inverse of our trig functions would be. And I'll show you why we're going to have to restrict the domain and the range of our trig functions in order to think of the inverses as functions themselves. So if we look back at, let's say, our sine graph, f of x equals sine x. And there's usually just one little piece of this graph we look at, but I'm going to look at a bunch of it. So just normally the sine graph, we just look at that piece. But I'm also going to look at what would happen if we went backwards a little bit. Technically, this graph goes on forever in both directions. The domain is negative infinity to positive infinity. It goes up to 1. It goes down to negative 1. It hits its high point there at pi over 2. And its low point there at negative pi over 2, 3 pi over 2. This value is pi. 2 pi is our period. That's the length of one full iteration of the graph. So this is our sine graph. Now, if we wanted to find the inverse of this function, what we learn in algebra class is an inverse switches the x and the y coordinates. But if you remember back in algebra, usually one of the things that we check before we do an inverse is we check to see if the graph is 1 to 1. And the graphical way to check for 1 to 1 is the horizontal line test. So you see, well, if I draw a horizontal line, is there any horizontal line that's going to cross this graph more than once? And there is, which means this graph does not pass the horizontal line test. This graph is not 1 to 1. And what that means is if I just take the entire graph right now and I try to find its inverse, the inverse is not going to be a function. So what we have to do is we've got to pick just a piece of this graph to work with. We've got to pick a piece of it that is 1 to 1 and goes through all the possible values. We always like to pick a piece that's close to 0. So what I'm going to do is I'm going to use this piece. This piece uses all my positive values. And then I'm going to pick a piece that connects to that that uses all my negative values. So I've got two options. I can either go forwards or I can go backwards. So if I go forwards, I'm just going to hit all those same positive values, and it's still not going to be 1-to-1. If I go backwards, I'll hit all of my negative values, and that piece is 1-to-1. So if you look at, I'm going to transfer this over, if you look at just that piece of the sine graph, I don't like that. It looks like that. There's 0, there's 1, there's -1. This value is pi over 2. This value is negative pi over 2. It goes through all of the possible y values between -1 and +1. And if you check it to see if it's 1-to-1, all of your horizontal lines are only going to touch it once. So it is 1-to-1 now. So we can find the inverse of just this piece, and it will be a function. So what we've done is we've restricted the domain for this graph. We've restricted the domain for our sine graph to be negative pi over 2 to positive pi over 2. We only want to use that piece of it. And then the range, we haven't left off any of the range. We're still using everything from -1 to +1. That's already the normal range of your sine graph. So we're still using all of our possible y values. So now I'm going to take just this piece and I'm going to flip it over the line y equals x. That's the graphical way to find your inverse. And it's going to give me my graph for sine inverse of x. So all of my x and y values are going to change, and my domain and my range are going to flip-flop. So if the domain for sine is negative pi over 2 to positive pi over 2, that's now going to be the range for sine inverse. And if the range for sine is -1 to 1, that's now going to be the domain for sine inverse. And you can also take the points on this graph and switch the x and y coordinates to find points on your new graph. So this graph goes through 0, 0. Our new graph is going to go through 0, 0. This graph goes through pi over 2, 1. Our new graph is going to go through 1, pi over 2. This piece of our sine graph goes through negative pi over 2, -1. Our sine inverse graph is going to go through -1, negative pi over 2. Now that might not be enough information to draw this correctly, so what you might also want to note is that the sine value at pi over 4 is radical 2 over 2. And if we switch those, pi over 4 is exactly halfway, but radical 2 over 2 is all the way out here. So that would be helpful. So that helps you to see the curve. And then negative pi over 4, negative radical 2 over 2, it's all the way out here. So that helps you to figure out exactly how the curve is. So that would be sine inverse of x. And by restricting the domain, it's now guaranteed to be a function. This passes the vertical line test. Each vertical line only crosses it once. So this is now f of x equals sine inverse of x. And you might also hear another name for this graph. Sine inverse is the same as arcsine. Those two are the same thing, sine inverse and arcsine. So now the domain for this graph, left and right, it goes -1 to 1. And range is bottom to top, -π/2 to π/2. This is just the flip-flop of what sine was doing because it's the exact inverse of the sine graph. So this is why on the calculator, if you ask what sine inverse of a negative value is, it's going to give you a negative answer because it's got to treat sine inverse as a function. Sine of a positive number gives you a positive answer. Sine of a negative number gives you a negative answer. That's the only way our calculator knows how to treat anything, is as a function. One input produces one output. Our calculator can't handle one input means two outputs. It can only do one, which is why it's important that we can't 100% rely on our calculators to do everything for us. We need to know on the unit circle that there are two places where sine can be negative. When we use our calculator as a tool to help us, we know that sine can be negative in quadrant 3 and quadrant 4. So when we're asked for a quadrant 3 answer, if the calculator gives us a quadrant 4 answer, we may have to manually, on our own, move that angle using reference angles into quadrant 3. So what the calculator gives us is helpful, but it's not always the final answer. So this is why the calculator does what it does, because the calculator treats it as a function. And this is our sine inverse function. So notice I used radians on my y-axis, but you could also use degrees. This would be 90 degrees, and this would be 45 degrees. Negative, sorry. This would be 45 degrees, 90 degrees. So we could do this in radians or degrees. Typically it's done in radians though, but you may see some problems in your homework where they ask for degrees. So the exact same thing would be done for cosine and for tangent. I'm not going to go through the whole entire process for cosine and tangent though. That would end up making this an hour-and-a-half video of just me explaining why the graphs look the way they do. But I do want to point out one of the most important things here is that this is quadrant 1 and quadrant 4. Zero to π/2 is quadrant 1. And then if you go backwards from 0 to negative π/2, negative angles go clockwise. So it's going to go down from your x-axis. That's going to put you into quadrant 4. So anytime you're using sine inverse, you're always going to end up with either a quadrant 1 or a quadrant 4 answer. Sine inverse always uses quadrant 1 and quadrant 4. So that's the important thing to note. Sine inverse will never give you back a quadrant 2 or a quadrant 3. It uses quadrant 1 for the positives, and it uses quadrant 4 for the negatives. So very, very quickly, for cosine, if you look at the cosine graph, it is slightly different. So I want to go through cosine really quickly. The cosine graph looks like this. And up here we have 1. Down here we have -1. There's 0, pi, π/2, 3π/2, 2 pi. We always want to use the piece that's at 0. We always want to use quadrant 1 for our positive pieces. But then we also want to use a piece attached to that for our negative pieces. We don't want to use the entire cosine graph because it's not 1-to-1. If you do your horizontal line test, you see horizontal lines cross it twice. Or if we were to continue this graph forever in both directions, it crosses multiple times. So we need to use just a piece of the cosine graph. So this graph goes forever in both directions. We only want to use a piece of this graph. Now, I don't want to go backwards the way I did with the sine graph, because that's just going to repeat all my positive values again. And it's not going to pass the horizontal line test. You see my little red dashed lines are going to cross again. I want to use a piece that's connected here that's now going to go through my negative values. So for cosine, I'm going to continue on to the right. So I've got all my positive values here from 0 to pi over 2, and then all my negative values from pi over 2 to pi. So we're going to restrict our cosine graph. We're going to restrict the domain to be from 0 to pi. If we only use the 0 to pi piece, we're still going through all the values between -1 and +1. But we'll pass the horizontal line test. Nothing's getting used twice. So I'm going to transfer that piece over. This piece now passes our horizontal line test. None of the horizontal lines will cross more than once, which means I now can find the inverse for it, and the inverse will be a function, which means one input will produce one output. So this is our restricted cosine graph, and I'm going to just identify some points to help me easierly, if that's a word, draw my cosine inverse graph. So my restricted cosine graph goes through the point 0, 1. So my cosine inverse graph is going to go through 1, 0. My restricted cosine graph goes through 0, pi over 2. So my cosine inverse graph is going to go through pi over 2, 0. And then my restricted cosine graph goes through pi -1. So my cosine inverse graph is going to go through -1 pi. And you might want to do your pi over 4s to help you with the curve. Cosine at pi over 4 is radical 2 over 2, which is still really close to 1. So pi over 4 is radical 2 over 2, which is still really close to 1. So that will help you see how the curve goes. So this is, and if you see now, it is a function because it passes our vertical line test. This is now a function. This is cosine inverse of x, or arc cosine of x. Those two are interchangeable. They mean the same thing. And the domain and the range we had earlier just flip-flop. The domain, that's the left to right, is -1 to 1. So you can plug in values for this function between -1 and 1. And the range, which is the important piece, these are the types of answers you're going to get back from the cosine inverse button on your calculator. You're going to get back answers from 0 to pi. So what quadrants are those? Answers from 0 to pi. That is quadrant 1 and quadrant 2. So cosine inverse uses quadrant 1 for the positives, and it uses quadrant 2 for the negatives. And then tan inverse does the exact same thing that sine does. It goes backwards for its negatives. So sine inverse and tan inverse do the exact same thing. They use quadrant 1 for the positives. All of our inverse functions use quadrant 1 for the positives. And then what quadrant they use for their negatives is different. Sine and tangent use quadrant 4. But cosine, if you remember on your unit circle, cosine is positive in quadrant 4. So we can't use quadrant 4 for cosine's negatives. We have to go to quadrant 2. So for positives, all use Q1. For the negatives, sine inverse uses Q4, tan inverse uses Q4, but cosine inverse, cosine is positive in Q4, so we have to go to Q2. Now, the reason we don't use quadrant 3 is because we need something attached to quadrant 1. I want two connected pieces. Remember up here on the graph, I want two connected pieces. I want a nice chunk of graph. If I were to do quadrant 1 and quadrant 3, I would have two completely disconnected pieces of graph. I don't want to do that. I want two connected pieces of graph. So from quadrant 1, in order to be connected, I've either got to go forwards or backwards from there. So quadrant 4 or quadrant 2. So nobody uses quadrant 3. Another thing to point out is that when sine inverse and tan inverse use quadrant 4, they don't use values between 270 and 360. They use negative angles. So they're always going to say negative 0 to 90 or negative 0 to pi over 2. So they always state those values as stated as a negative quadrant 1 angle. So I'll go through some examples. This is a lot of new information, might be kind of confusing. Hopefully when we look at some examples, it won't be too bad. So most of these you're just going to do on your calculator. Some of them you may be able to just look up on your unit circle. Just be really careful when you look them up on your unit circle. You have to know what quadrant to use. That is the trick. So if you are asked to find so first of all, just the general directions are to find the indicated values. We want to find sine inverse of negative radical 3 over 2. This is a sine inverse question, which means we need to think of this in terms of inverse trig functions. We've got to follow the rules of inverse trig functions. So sine inverse is negative. You technically can just plug this straight in your calculator. You should be able to plug all of these straight in your calculator, especially if they want you to answer in degrees. The answer to an inverse trig is always an angle. The only thing you need to be careful of when you're answering your homework and you're doing your test is whether they want that angle in radians or degrees. If they want the answer in radians, what I suggest you do is you ask your calculator in degrees first, and then use that answer to find the radians on your unit circle. If you ask your calculator to do a radian answer, it's always going to give it back to you as a crazy decimal because your calculator will not give you an exact radian answer with a pi in it. So right now we're just going to do these in degrees so I can show you what it looks like just typing these in the calculator. And unfortunately I don't have a calculator app on my computer where I can show you what I'm doing. But exactly what I'm doing, I'm going to make sure my calculator is in degree mode. Make sure your calculator is in degree mode. And then I'm hitting second sine. And that's how we get sine inverse. And then I'm typing in negative square root 3 divided by 2. And be careful, depending on what type of calculator you have, there might be some parentheses that automatically open. You need to make sure you close them. The calculator says that this answer is negative 60 degrees. You do not need to do anything to that answer. Now, back in chapter 6, we might need to adjust that answer and move it to quadrant 3 or add 360 so that it's a quadrant 4 answer. Because this is an inverse trig question, it is perfectly acceptable for a negative inverse sine question to come out as a negative answer. Sine inverse uses quadrant 4 for its negative questions, for its negative values. And it gives the answers back as negative quadrant 1 answers, negative quadrant 1 angles, negative 60 degrees. Now, if they asked us this question in radians, all you need to do is go to your unit circle and figure out what 60 is in radians. You should have a completed unit circle. There is one available to you on our Moodle page, a completed unit circle, already done. And 60 degrees is equivalent to pi over 3 radians. So if they asked you to do this in radians as an exact radian answer, your calculator will not do exact radian answers. So it will do exact degree answers. So once you get negative 60 degrees from the calculator, you can just look on your unit circle and say, oh, well, 60 degrees is equivalent to pi over 3. So this is negative pi over 3. So just be really careful about whether MyLabs Plus is asking you to answer in degrees or radians. Sometimes it will say it specifically in the problem, and sometimes the only way that you'll know is that you'll have your answer box and there will be a degree symbol afterwards. So that's what's going to tell you they want the answer in degrees. So you'll just put negative 60. Let's try another one. So that one was A. Let's do cosine inverse of negative radical 2 over 2. And we're going to do this in degrees and radians. So I'm going to do it in degrees first, and then I'm going to use my unit circle to help me change it to an exact radian measure. So make sure your calculator is in degree mode, because your calculator will do an exact degree first. So do second cosine, and then negative square root 2 over 2. Enter. And I've got 135 degrees. That is because cosine inverse uses quadrant 2 for its negative values. We said that earlier. Cosine inverse uses quadrant 2 for its negative values. So it makes perfect sense that we got a quadrant 2 angle when we asked cosine inverse of a negative. And now look on your unit circle and see what the radian equivalent for 135. So if we were asked for a degree answer, we would say 135. If we're asked for a radian answer, we would then look to our unit circle and see what 135 is equivalent to on the unit circle. And you should see that 135 is equivalent to 3 pi over 4. So if they wanted radians, we would just have one extra step, and that would be to convert that with the help of our unit circle, 3 pi over 4. So this is an or. You would not give both answers. It all depends on how the question is worded. So there are a few that are a little bit harder, and those have to do with our reciprocal functions. If you were asked to do, for example, cotangent inverse of let's say cotangent inverse of radical 3. What we've been doing is second and then your trig function. We did that for cosine inverse. We did it for sine inverse. The problem here is we don't have a cotan button. We do not have a cotan button, so I can't just hit second cotan. What we need to do first is we need to fix this. Off to the side here, I'm going to show you how to fix it so that we can use our calculator. So cotan of theta is equal to some value. I'm just going to call it A. And we can change that to a different trig function by flipping it. So if I flip both sides of this equation, cotangent flipped is tangent. And then A flipped is 1 over A. So to go from here to here, I'm flipping everything. Now to solve for theta, we move the trig function to the other side using inverse. So theta is tan inverse of 1 over A. Up here, theta was a cotan inverse of A. So we can change a cotan to a tan if we flip the number that's inside. We can change between our reciprocal functions when we change the number that's inside the parentheses, if we flip the number that's inside the parentheses. So I can change this cotangent problem to a tangent problem. So this is exactly the same as asking tan inverse of 1 over radical 3. That's the exact same question. And that one I can do on the calculator because we have a tangent button. So in my calculator, I can say second tan (1 divided by square root 3). Enter. And I'm doing this in degree mode because our calculator will give an exact degree answer. And I get 30 degrees. And then if we were asked to do it in radians, I still do it in degrees. I would just have one more step, and that would be to use my unit circle. And I do have, let me see if it's not filled out. I was going to say, I've got a blank one there. Use your unit circle to see what the equivalent for 30 degrees is in radians. So if you were asked to do this in radians, you would just look on your unit circle and say, that's the same as pi over 6. One more real quick, because there are some other ones where they don't care if your answer is exact or not. There are some that they just flat out say, just type this in the calculator and tell me what you get. And just for some more practice, I'm going to do another reciprocal function problem. So if we were asked for secant inverse of 1.1677 to the nearest hundredth of a radian. Secant inverse of 1.1677 to the nearest hundredth of a radian. So a lot of you are getting problems completely wrong, especially on your test, because you're not rounding correctly. You're completely disregarding the rounding instructions. So you need to be looking at those rounding instructions. Hundredths means keep 2 decimal places, and you need to look at the 3rd decimal place to help you decide how to round. So 100th of a radian means I need to do this in radians on my calculator, and I'm going to keep 2 spaces. I'm going to look at the 3rd space to help me decide if I need to round it up or keep it the same. Now, I don't have a secant inverse button, so I can change this to its reciprocal function. So you need to know what the reciprocal function is for secant. It's cosine if I flip the number inside. So 1 over 1.1677. And we'll type that in the calculator as secant cosine 1 divided by 1.1677. And make sure that you are in radian mode, because the directions for this problem specifically say radians, and it doesn't say we need an exact radian answer. It says a rounded radian answer. So we don't have to worry about unit circle values and pi's and things like that. So make sure you're in radian mode. So my calculator says, and I'm going to write a bunch of the decimals, 0.5425703399. That's the entire number my calculator says. And we want to round it to the nearest hundredth. So this place is the 10th, and this place is the 100th. So we're either going to write 0.54 or 0.55. It all depends on this number. If that number is less than 5, then we're just going to forget this stuff. If that number is greater than or equal to 5, then we're going to round up. And we're going to write 0.55. But since that number is a 2, we just get to forget all that stuff. So our answer to the nearest hundredth of a radian is 0.54. 0.54 radians. The other type of problem in this section is composition problems. And you really just need to think of them as 2 problems. Some of them you can just do straight from your unit circle. And then a few others you can't, and I'll show you what to do if you can't use your unit circle. But just think of these as 2 problems. And you also need to remember your order of operations. You always start inside the parentheses first. All these composition problems will have a set of parentheses. So composition means that one function got plugged into another function. So let me show you an example. Sine of cosine inverse of a half. Sine of cosine inverse of a half. So first and foremost, we want to do what's in the parentheses. We want to find cosine inverse of a half. This is our first step. So what is cosine inverse of a half? We can type that in the calculator. Ask the calculator what cosine inverse of a half is. So second cosine, 1 over 2. I would put your calculator back in degree mode. I just had it in radians and got something crazy. It's 60 degrees. The entire inside is equal to 60 degrees. So now it's asking me what sine of 60 degrees is. So look on your unit circle. What's sine of 60 degrees? It's radical 3 over 2. That's it. You just got to think of it as two problems. The inside is the first problem. Once you get the answer to the inside, you then can work the outside piece. Now, some of these are not on the unit circle. And let me show you an example of that. Cosine inverse of cosine of pi over 7. Now, the trick with this one is knowing whether or not that angle is going to be in the domain of cosine inverse. Is pi over 7, not the domain, the range, is pi over 7 in the range of cosine inverse? Typically, when we see a function and its inverse right next to each other like that, they're supposed to cancel each other out. If you see plus and minus the same thing right next to each other, they should cancel each other out. If you see multiply and divide by the same thing right next to each other, they should cancel each other out. Back in algebra class, when you saw that you're going to square a square root, they cancel each other out. Cosine and cosine inverse are the exact same thing. The only thing you need to be careful of is whether this angle is an answer that cosine inverse is allowed to give. Is cosine inverse allowed to give pi over 7 as an answer? And the way that you decide that is just decide what quadrant it's in. What quadrant is pi over 7 in? Pi over 7 is in quadrant 1. Does cosine inverse ever use quadrant 1? It does. Cosine inverse uses quadrant 1. Wonderful. Those are going to cancel each other out. The answer is pi over 7. Sine of sine inverse of pi over 13. This has me suspicious. Those guys are inverses of one another. We just need to check and make sure, that is, I'm sorry, this is not correct. I put an angle inside of an inverse function. I think this one always ends up working. I think it's only when it's outside that it doesn't. Yeah. Again, sine and sine inverse right next to each other. They will cancel each other out. Answer is radical 3 over 2. There are a few where you need to be kind of tricky. And I'm going to show you one of them real quick, and then I'm going to end this video because it's already 45 minutes. And of course, these are my favorites. The tricky ones are always my favorites. So, if you were asked to find the tangent for cosine inverse of 2/5. The tangent for cosine inverse of 2/5. We want the exact value for that. This is a super fun problem. You're not going to think so probably, unless you love math and you love math type puzzles. So start with the inside and start with what this means. Cosine inverse of 2/5. What is the answer to an inverse trig problem? I said it earlier. The answer to an inverse trig problem is always an angle. So I'm just working with the inside right now. Cosine inverse of 2/5 is going to give me some angle back. I'm going to rearrange that equation, and I'm actually going to move this thing to that side. And when I do that, it turns into a regular cosine. So 2/5 equals cosine theta. Okay. So I'm working with a right triangle that has a cosine value of 2/5. I'm going to go ahead and see what that triangle looks like. So there's theta. Cosine uses adjacent and hypotenuse. And I can use the Pythagorean theorem to figure out the third side. So a squared plus b squared equals c squared. So 2 squared plus b squared equals 5 squared. So that's 25 minus 4 is 21. So this is square root of 21. We're being asked to find tangent. Well, tangent, remember the answer to inverse trig is an angle. Okay, I found the angle. There it is. Now I want to know tangent. Well, tangent is opposite over adjacent, so the answer is radical 21 over 2. That is one of my favorite problems. It's kind of crazy. You might not know what just happened. But the inside information, if this is not something you can do on the unit circle, the inside information is just used to help you set up the triangle. And then the outside information is actually the question you're trying to answer. So if they give you some really weird numbers that you know are not special angle numbers and they're not unit circle numbers, you can use them to set up a triangle. Just set up a triangle. Fill in your third side, and then the outside trig function is the question you're trying to answer. So that's always a possibility as well. So I hope this helped a little bit, at least with section 4. A lot of it can be done in the calculator, and this is also why back in chapter 6 we couldn't always rely on those the inverse button. Sometimes we had to adjust that answer a little bit. So this also maybe cleared up some of the questions on why did the calculator not always give us the answer that we wanted. Why did we have to move it? Why did we have to adjust it? So this is why. It's because we've got to treat that inverse trig as functions. One input equals one output. So a lot of this stuff can be done in the calculator. You may have to do it in degree mode and then use your unit circle to help you switch it to radian mode if they want an exact answer. Some of the other ones, they don't want an exact answer, and you can just put it in degree mode and use a decimal. And then with the composition problems, if it's two different trig functions, you just want to do the inside first and then the outside. If it's the same trig function, they'll usually just cancel each other. And if you recognize the value in there as not a special angle or not a special unit circle value, those ones can be a little bit trickier, and you'll want to use that information to set up a triangle to get your answer. So I'm going to make also a video in just a little while for 7.5 for you to use, hopefully to help you with your homework tonight. 7.5 is solving trig equations. And I will get that to you very shortly. And I'm also going to go back and make videos for Section 2 and Section 3, so you can have those before your Chapter 7 test.